Okay, we have here today an interesting integral. This one's from Swinbee 2018, problem 15. We have the integral of x to the 8th times e to the x to the 3rd dx. Okay, now at first this looks kind of tricky because we have x cubed here. We really don't want that. So what I want to do first is I really need to simplify that. And so what I'll do is we'll just try a u substitution on this. So I'll just set my u equal to x cubed, simplifying this exponent. Then let's take a derivative. So for du, we end up with 3x squared dx. And then from here, it looks a little complicated still because if this is our du value, well, we have an x to the 8th here. It doesn't really match this. Well, what I can actually do is let's rewrite the integral. And first what I'll do is kind of create this at the end. So I'll just force this 3x squared dx over here. We'll just copy this part down. And then to make this work with x to the 8th, well, first of all, I can multiply by 1/3. So the 1/3 times 3 is just giving me this 1 here. And then in order to get x to the 8th, I can write this as x to the 6th. So then this times this is still just x to the 8th. But then for this x to the 6th, I just want to set it up so I can do a u substitution. So let's just change this exponent. Instead of writing it as x to the 6th, I'll write it as x cubed all squared. And so now this piece here, this is actually just going to be u squared. So now I think we're ready for the substitution. To start, I'll just take this 1/3 and we'll bring this out front here. This piece here, this is actually just going to be u squared. Here we have e to the u, and this thing's just our du value. But now for this integral here, we can just do this with integration by parts. I'm going to do the di method or tabular integration over here to the right. And I definitely want to differentiate the u squared because if we differentiate the u squared, it's going to simplify and eventually differentiate to 0. So let's see how this works. We'll differentiate u squared and we'll integrate e to the u. Take a derivative here. This is going to be just 2u. Do it again. This is just going to be 2. And do it one more time. And we get our 0. Here, the integral of e to the u is just going to be e to the u. And we'll just do this 2 more times. And it's all e to the u. So now because we have a 0 here in the last row, this integral is just going to be 0. So I'm going to ignore this. And we'll just go to our solution, which is going to be on these diagonals here. But now you'll notice every single term has an e to the u in it. Okay, so when we copy this down, I'm just going to factor out an e to the u of each term. So I'm going to write this as e to the u, and then copy down the stuff here. So we're going to have u squared minus 2u plus 2. But now I can just back substitute in order to finish it off, just noticing u is x cubed. So we're going to have, for the final solution, this is going to be e x cubed. This here I can write as x to the 2/3. No. Then for u squared, this is what we had over here. This is actually just x to the 6th minus 2. This is going to be x cubed plus 2. Add a plus c, and that's it. But unfortunately, I forgot this 1/3, so let me do this over again. But of course, we have this in front, so divide by 3, add a plus c, and that's it. Okay, so there you have it. Good problem from Swinbee 2018. Thanks everyone for watching. Have a good day.